So today we have the CISL seminar, and we're going to be covering crossing the chasm at NASA Earthdata and NOAA Fisheries with Danny Kaufman, Amy Steiker, and Julie Lowndes. Sorry. Looking forward to it. Let's get started.
All right. Thank you so much for the introduction, and thank you so much for welcoming us today. It's such a pleasure to be here in person. Thanks for the intro again. We're going to be sharing some really exciting work across both NASA Earthdata and NOAA Fisheries when it comes to crossing, in some cases, big, scary chasms. And Julie and Danny, if you wanted to say hi as well.
Hi, yeah, great to be here with you all. Thanks so much for the invitation. Looking forward to this.
Yes, hi everyone. It's great to be able to share some of this work with everyone at NCAR and CISL. Really cool.
Yeah, great. All right, so we'll get started here. So first, just kind of walking through kind of who we are and a little bit about NASA Openscapes. Both Danny and I kind of represent and work for NASA Earthdata. We are both at different NASA Distributed Active Archive Centers. Julie, as director of Openscapes, is leading and helping to grow this really wonderful mentor community across these NASA Distributed Active Archive Centers, or DAACs. And we really do have a long history here. We started off in early 2020, so over 5 years now of working together. And we kind of all meet in the middle of this Venn diagram. So this group of individuals, we have backgrounds in environmental science, in kind of data science and software engineering, and also kind of practicing and evangelizing open source and open science best practices. And so again, we all kind of meet in the middle to mentor, teach, and empower our user communities. And so you can see Julie, Danny, and I, this was actually taken at an in-person retreat that we did the day before the ESIP summer meeting in 2023. Since we started off, though, in early 2020, we've sort of weathered the pandemic together, working remotely, and this was a really special time for us this was really the first opportunity we had to sort of be in person together 3 years later. But ironically enough, many of us got very sick at the end of that conference with COVID and other illnesses, but it was wonderful to be together while we were all still healthy. So we are going to talk, I'm going to start us off kind of talking about crossing the chasm at NASA Earthdata, and in particular, really focusing on this exciting story of building the open source Earth Access community, which is a Python library, and what this is kind of meaning in the current time, and kind of looking at this library as really broadly enabling the access and utility of NASA Earthdata as a whole. And again, how the NASA Openscapes community has enabled that work. So talking about crossing the chasms, what do we mean by this? So I'll get into this a little bit more in the next slide, but the overall concept here is that there can be sometimes a very large chasm between sort of an innovative idea, the early adopters to take on that idea, and more broad adoption across a larger audience. This can be hard to define, though, but this concept and metaphor was introduced and presented by Eli Holmes at NOAA Fisheries. Again, Julie will speak to this more later in that story, but presented this at the Cloud Native Geospatial Conference this past spring. But she sort of started off with presenting this idea and this concept in the context of big organizational change. And so one thing that's wonderful about Openscapes is this concept of forking and sharing ideas. And so we've thought about, hey, how can we utilize, or how can we think about this metaphor in our own context within NASA Earthdata? So back to NASA Openscapes and going into this crossing the chasm sort of theory in a little bit more detail. So this book by Jeffrey Moore talks more about this diffusion of innovation theory. And again, this idea of that chasm that could take place between, as we start off with innovation and early adopters and getting to the point of how do we expand and have a larger majority adopt that idea. And I want to really emphasize that NASA Openscapes, again, bringing together this kind of diverse group of people for a specific cause or specific goal, really was critical in order for us to kind of form new ideas and innovate. And actually, just going back real quick, another thing I want to point out that's important here in the context of Earth access, if I can give kind of a one-sentence blurb on sort of the goals of NASA Openscapes effort, it was really about, and continues to be about, this broad goal of teaching and supporting researchers' migration to cloud computing workflows. So that was really what we were tasked to do. So when we think about chasms, I think, and reflecting on the Earth access story and the origins of this Python library, which I'll get into more, we recognize right away that as we jumped into, helping researchers with cloud computing workflows, we realized there was this large chasm between that, the users and their existing workflows and that adoption. So backing up quickly, NASA Earthdata and all of the remote sensing holdings of NASA Earthdata, have traditionally reside on on-premises hardware across this distributed system of archive centers. So for many years now, there's been this very large effort to migrate all of the data holdings to the commercial cloud into AWS. So as we've been doing this, we started to directly work with the research community to understand what this means for them and even what this means for us as mentors. And we started to quickly realize that there's this rain cloud over these research groups and even ourselves as we started to realize what this actually means to transition workflows. So all of these barriers existed as far as formatting each search term for dozens of independent systems across data centers. There was another, and still is, an additional credential layer sitting on top of the existing kind of login system for accessing the data due to kind of additional security platform over our AWS holdings. And then even just having to completely change a workflow, whether it's programmatic or just through an application when it comes to both in-region access if you're streaming versus local download, and even just interacting with cloud-based storage and even knowing what object storage even means, right? So we started to realize, man, all of these complexities should be more transparent and should be abstracted from the user. This is sort of, implementation details that users don't need to do. So Earth access was sort of born out of these challenges that we identified through this direct engagement with our user communities. And now, in really just 3 simple lines of code, you can, after importing the library, you can authenticate against the Earthdata login system. You can do a single kind of spatial query, or a dataset query. In this case, you can input a dataset DOI, a temporal or spatial bounding box filter, and then input those results directly in Xarray. So we also are thinking about meeting users where they are. Xarray is a very common package that our users work with. Much of NASA Earthdata is in multi-dimensional HDF or NetCDF files. And so, we wanted to go that one step further instead of thinking so solely around Earthdata components. How do we integrate into existing open source packages? And I'll also argue here that the sort of gray rain cloud was in a lot of ways a direct result of some of the siloing that we had seen across our organizations. Again, we have these distributed centers. Sometimes we're really working in very siloed ways. So we may have been checking these boxes as far as, okay, the data are available, they're in S3, but what does that really mean for the user community? So this is, again, where we were able to come together and think about this more holistically. So this is a theme we'll keep coming back to as far as both the technical and social infrastructure and this kind of critical interplay between both the people and then the tooling, right? So it's one thing to kind of say, great, let's go ahead and build a library. But it's another to ensure that there's the right kind of community and culture in place to kind of make that happen. And although this sounds very simple in practice, we've recognized that it can actually be very hard. And it has to be very intentional. So again, this mentor community is very unique, and it's hard to quantify what it feels like to be a part of this. But it's a place where we really feel comfortable asking questions, working together, where we hadn't really felt that comfort before. So we'll come back to this theme a little bit more. We'll see this at multiple levels, touching on it with Earth access. Danny will then kind of touch on this theme as well when it comes to how we've applied these practices to a new NASA Earth science mission, the TEMPO mission. And then Julie will kind of bring it all home, talking about the Openscapes framework and this flywheel as a mechanism for this sort of feedback loop. So a little bit more about kind of, all right, where we've come to at this point, still in that kind of early adopter phase of that diffusion of innovation, right? So we'd recognize even with this, just kind of this early adopter sort of grassroots a movement, I should say, and kind of effort and project around Earth access. Like, sure, we built this around this need to help users kind of migrate workflows to the AWS cloud. But we've seen a lot of positive feedback on this, especially because it's a very unique, compared to other tools and services and components that have been built by NASA Earthdata. People recognize right away how unique this is because of that intentional, community-driven way in which we started off Earth access. So, we've heard some good feedback from folks at NASA missions. We have over 200 dependent projects that utilize Earth access, and all these really great things, which is awesome. We made sure that it's advertised on the NASA Earthdata site. I'll touch on the Hack Days in a minute. But this also, I think, is pretty groundbreaking for NASA Earthdata as well, because of the ability to, have a very reproducible workflow that didn't really exist before through this library, increasing that collaboration and also transparency. And just a note on this too, just kind of a snapshot of the contributors to this library, and I'm not going to go through all the acronyms. It's okay if you don't know all the acronyms here. A lot of them are some of those distributed active archive centers or DAACs, like ASDC, JESDIS, et cetera, which is great. That alone, I think, is really powerful because we do have we have dedicated time to work on this, even though it's not directly sort of funded. It's sort of this offshoot origins based on NASA Openscapes, but we are able to dedicate time towards it. It's not solely volunteer. However, we've had really amazing contributions from citizen scientists, from industry at companies like Coiled and Development Seed, from other agencies like the USGS, and even NASA headquarters, which I think is really special too. So they've kind of seen the unique value of, again, doing something intentionally community-driven, and how powerful that's been. So getting into that a little bit more, I've already mentioned we built this with this intentional culture and community, leveraging all the wonderful things that Julie does through Openscapes, and that's been critical to its success so far. But as we're kind of thinking about where we are in the moment, we're realizing how important it is for its future growth as well. So we've been developing these community partnerships, these collaborations with other open source communities like Xarray, Pangeo, the HDF group, OpenDAAC, of course, Openscapes, developing these ways to work together through hackathons and workshops. But we're starting to kind of think about how important that is to have that foundation, especially, again, in this place of 2025, like, no doubt it's not a very certain time. We didn't have direct funding even before before this year, and we're realizing how robust we are even in these uncertain times. So we're now kind of starting to ask ourselves bigger, broader questions, and we're realizing that Earth access is actually kind of this bridge, more broadly thinking about a bigger target population of just enabling the ability to utilize NASA Earthdata as a whole. So we're kind of asking this question now, like, hey, we're robust here. We have this strong, broad community. How do we help, more broadly users leverage the awesomeness of NASA Earthdata? And so the shift really now is thinking about, like, well, okay, who can help build this bridge? So as we think about this vision for that majority, how do we kind of cross that chasm when Earth access is, maybe not only meant to just kind of solve these initial cloud workflow transition problems, but what else could this mean for us? And so I love Andy Barrett, one of our colleagues, also at NSIDC, kind of called it like batteries included. Like, how do we think about this library to help enable and make it easier for users to adopt and utilize NASA Earth data? So some of the questions, again, asking this question of widening the bridge, some of the things that we're looking at, and this first item will segue into Danny's talk next, but we're looking at Earth access as now, like, this can actually truly enable real-world analysis at scale. Again, we started off with this very specific problem to abstract the complexities of our Earth data components, make it easier to migrate to the cloud because the code is the same now, whether you're in the cloud or not. So how can we enable real-world analysis at scale, especially in this context of large missions, data volumes growing, et cetera. So Danny will speak to on-demand virtual data cubes next. I think something definitely of interest, thinking about cross-agency collaboration. This is specifically for NASA Earth data. That's where we started off, but we've really been thinking about, again, leveraging broader partnerships and expanding this. This doesn't have to just be NASA specific. So can we look at things like stack integration, the spatiotemporal asset catalog, to utilize that to pull in and use the same workflow for much more than just NASA Earth data, but other science data. And then something that I'm particularly interested in around kind of community management and evolving our kind of community governance, and how do we continue to lower barriers to library contributions. So just wrapping up on my end here, these are kind of the questions now that we're asking ourselves, and of course would love feedback from the audience too. How do we continue to increase these partnerships and external funding? How can we learn from and further stories that already exist? And I really want to emphasize this last question in the middle here is instead of we've been asking this question of like, how can we get more support? How can we get more funding, et cetera? Flipping it the other way, how can we actually support NASA Earth data? And it's a really cool spot to be in right now where we can ask that question. So this is just a quick kind of, hey, come work with us if you're interested in these types of problems that we're trying to solve as far as enabling big, large-scale data access, and integrating with other kind of other Earth science data, Python packages, et cetera. We do these bi-weekly hack days. The next one's coming up on Tuesday. You can connect with us. Folks can maybe put these links in the chat if possible, but but our repo's here at github/NSIDC/earthaccess. And we'd love to get feedback from you all. So with that, I'll transition over to Danny to kind of keep this moving on the cloud access virtual data set front and the involvement in those user communities that Danny supports.
Yeah, sounds good. Yeah, thanks, Amy. This is gonna, let's see, yeah, looks like the slide's up. So yeah, I'm gonna just say click to advance the slides, but I'm Danny Kaufman, and like Amy, I'm at one of the data centers for NASA, and what I want to share here is talking about expanding beyond the core ideas of Earth access on making data accessible, and now kind of taking the same synthesis of tooling and people and a community-first approach to improve the performance of that access and work together as a community to not just develop an idea in isolation, but to develop it in that collaborative fashion. So I'm going to talk about sort of the technical part of that first, the technical innovations part of that first, and then I'll share a little bit about a workshop that was that built on that further. So if you click. So this all revolves around this common researching bottleneck. This might sound familiar. Spending a whole day downloading data, working to try to download data, maybe failing a couple times and getting it, or maybe it just takes forever to download data, and then you end up with just a short bit of analysis that you have to do at the end. And if you click, and this the context for this includes a bunch of other challenges as well. So if you need a data set, this one challenge of taking a long time to download, you're in a queue, that's one part of it. But then you may also run into, well, there's storage limits. So say you download some of it and then you run out of memory. then you have to start again and reevaluate like what's the scope of this problem I can actually address. And ultimately that ends up with, and often the case being that you limit the scope in order to be able to do an analysis quickly. So if you click, this leads to both things, either spending more time doing the data processing part and less time actually doing analysis and gaining insights, and or limiting the scope because of the limitations on time or other resources. Okay, click. So the solution to this, or one solution to this for NASA Earthdata is this approach called virtual data sets or virtual data cubes. And this is the purpose of this is to get to that those analyses in minutes instead of hours. So this is just an illustrative thing on the slide right here, just to show, you can see a snippet there that some of the virtual data set functionality, you'll see words like Earth Access .open virtual MF dataset. It's the incorporation of these virtual data set paradigms into that Earth Access package that Amy talked about. And this relies on a couple of components of the data, and then building some new components, which are illustrated in that diagram, which I'm going to come back to in a few slides. The result of this, if you click, is getting to analysis quicker. So this is an example in the top right showing a spatial subset, which represents an average over a whole year's worth of data from this TEMPO instrument, the TEMPO being a satellite instrument that measures air quality. And so this was built, this image came from 5,000 different data files representing 2.5 terabytes of data. And we did some benchmarking, and that's what's shown in the bottom right. You probably can't read the numbers, but you might see a few dots. The dots on the right-hand side correspond to the x-axis, where it would take about 24 hours to generate this plot if you were going to download all of the data, and we went to about 10 minutes for generating this plot using the virtual data set approach. Okay, if you click. Okay, so the technical innovation part of this is the first part. So if you click, this is to provide a little bit of explanation of how this actually works. So you have an idea of why and what's going on. So traditional files in the cloud, they don't necessarily provide an optimized experience for data access. Traditional files on a high-performance supercomputer that's local may be great, but if you're trying to work with these in the cloud, you end up with a couple of issues. And this comes from the structure of these files. This is the schematic shown here. You see green blocks and orange blocks, the green blocks being the raw data, and orange blocks being the metadata that refer to where the data are within the file. So because these are scattered throughout the file, if you click, Amy, this ends up leading to an excess number of HTTP requests or just over the network requests to access all of these different metadata blocks, just to find out where the data are in the file that you actually need to do whatever analysis you're doing. So if you only need 1% of the data in a file, well, too bad, you actually have to download the whole file to then figure out where it is in there. So the alternative approach, if you click, with the virtual data sets, is to separate the metadata and take all of the data and put it in kind of up front, so that way the requests over the network can go right to the metadata. They don't have to scan through the file to find those metadata, and those act like a table of contents that then the data analysis can jump right to the location of the data when it needs to. If you click, so this, if you have heard the term ZAR format, this mimics the structure of a ZAR format. So that's just a native format that does this. But for HDF and NetCDF files, it doesn't natively do this. So we need to create this this virtual table of contents. The term that's used the more technical term for this is a chunk manifest. And that word is just referring to the fact that the manifest, it's like an inventory of what's in the file, and it's a manifest of all of the data chunks. And each data chunk is a range of bytes for every data array. So this is what we are talking about when we talk about a virtual data cube, and what we're aiming for to provide performance improvements. So if you click, Amy, if you wanted to see what this looks like, if you have a visual in your head, this is actually what's in a chunk manifest. On the left is just the example table of contents. So just like a book table of contents where you have page numbers listed, so that way you could flip through the book immediately and go to the section you want. What the chunk manifest provides is it tells you a path for a chunk, and then you see an offset and a length, and that tells you where to start reading the bytes and how many bytes to read for that chunk. So there you go, you have all of the information you need, more or less, to get to any data chunk. If you click, Amy, so this provides faster cloud access by separating that metadata into this chunk manifest. And importantly, for a lot of the NASA data holdings and for other organizations' data holdings, it doesn't require converting the data and duplicating the whole set of data just to provide this access. You are working with NetCDF files just with an additional chunk manifest. Okay, so if you click. So how this works from like in the process, in a process approach, it's in the NASA archives, we have all of these NetCDF files, and these have, for Tempo and for some other collections, we have these chunk manifests formatted as a specific type of file. DMR++ is the name for it. That acronym is not important, but it's a chunk manifest for each file. And those get parsed first. So if we click, we parse each of those chunk manifests for each file. If you click, then we do a step where we combine all of the references, all of these chunk manifests into one large chunk manifest that has the information for the entire data collection. So for Tempo, for a particular mission, this would be a chunk manifest for all of the NetCDF files for the entire mission. This could be thousands and thousands of files, but they're all contained within one chunk manifest, a small file that's the table of contents to the whole data set. If you click again, now this combined chunk manifest can either be held in memory if you're going to keep working on it, or you can write it to storage and then provide it to someone else, or NASA can provide it and make it easy to access the whole collection. If you click again, once you have that, you get these performance improvements because you can read those references and jump to any particular subset in the data directly, and you don't have to do all of those excess GET requests. You don't have to download 100% of each file. You can download those 1% of each file. Okay, if you click again, and you end up with your time average map much quicker. Okay, click once more. So this whole process by which these chunk manifests become usable relies on a bunch of different tooling, and because it relies on different tooling, it also relies on different organizations and different groups of people, or people across different organizations to make this work. So you'll see here icons or logos for Xarray is used for that combination of all of those reference files. Virtualizr, this other package on the left, this provides an interface with Xarray, and it provides for the representation of these chunk manifests. OpenDAAC worked on the specification for these particular DMR++ files. And then Earthdata, like Amy was talking about, provides this really streamlined way for folks to find files. And they could also use Earthdata to find these virtual representations of the data sets as well. Openscapes has really provided an opportunity. The Openscapes has provided the space and the sort of community mechanisms in order to facilitate all of these groups coming together and working collaboratively to make smart architecture choices and to develop collaboratively, to learn together, and to problem solve collaboratively as well. So Amy shared about the Earth Access Hack Days that happen every bi-weekly, and those are open because just like she invited everyone to come to that, we have folks from Virtualizar and Xarray and OpenDAP that will occasionally drop in, and we talk and we kind of work through some of these choices, development choices and community choices to make this work efficiently, breaking down some of those silos along the way. So we'll see the bullet points here saying that we made choices like moving parsers from one of these packages to another. So that way we avoided duplicating development time, and because it made more logical sense to have it in one package than the other. We had OpenDAP participants helping to improve the parser that was in Virtualizar. And ultimately, this all results in reduced maintenance burden for all of these packages, and it simplifies the APIs between the packages and for the data users as well. Okay, next slide. Okay, so that was this sort of technical innovation specifics part of what I wanted to share. The next part was kind of another step, another avenue by which we can leverage the people part of this to improve both the development experience and then the end user experience as well. And that was this workshop that was focused on the Tempo air quality mission, but this was another opportunity for community-driven development. So if you click, what we ended up doing for this workshop, and I'll say why I said we ended up doing, but we ended up with this mini workshop. It was a 2-hour workshop, very small. If you click, actually, Amy, this was an opportunity to test and to work on the virtual data sets in practice with folks. So the screenshot here shows a Jupyter Hub, a cloud computing space online in the AWS cloud, and we had 9 participants, both from the NASA data centers, from there's a user working group that we were able to draw from people that were already interested in NASA, working with NASA data. We also had someone from EPA and from different NASA centers. The goal was to support users that were already motivated to help them figure out how to utilize these cloud access approaches, and we ended up what the main mechanism by which we did that was to explore tempo data using virtual data sets. If you click, Amy. What you see on the right-hand side here was a drafting of the outline for this workshop. So this is why I said what we ended up doing. You'll see at the top, we said cohort, workshop, hack week thing. This was an opportunity because this was worked together with Openscapes, we were able to build on all of the previous experience that the Openscapes folks had with previous workshops and previous trainings. We have folks that are real experts in communication, able to kind of work together on building a workshop and to do it fairly quickly. So Amy, if you click again. So during Openscapes co-working sessions, these are like another meeting space along with the Earth Access Hack Days. During those sessions, we had planning and guidance for this workshop. We used the Openscapes computing resources, the 2i2c Jupyter Hub, to make it really an easy setup and make a consistent experience for the workshop participants. And even during the workshop, we had Openscapes folks so that we were able to talk through things during the workshop. If you click once more, Amy, this was really quick to come about. In 4 months, we went from, during a user working group, we had this idea to maybe have a mini workshop to test out some of these emerging approaches. And we went from discussing it the next month, outlining it, sending invitations, and delivering the workshop in August. Okay, could click to the next slide. The workshop both had the technical impact as well as a people impact. On the technical side, all the participants had hands-on practice with virtual data sets and being able to see what the benefits were, but also where it can be further improved. We worked through some problems in real time during the meeting, and we even identified improvements that we could take to Earth Access and the other packages. So we were able to create GitHub issues that we could then come back to for further development. On the people side, if you click, the participants had an opportunity to gain a little bit of confidence with this approach, as well as the facilitators gaining confidence. We had, like I mentioned, we had different people from different centers, as well as EPA there. So it's an opportunity to build out the people connections. And ultimately also to kind of help build champions for this virtual data sets, folks that know what it is, who can speak to what are the benefits, what still needs to be done, and kind of will help us and the whole community cross that chasm. Because now I think Earth Access has already crossed the chasm into some broader adoption, and virtual data sets is still really in this early adopter phase. And this is kind of how we're going to work towards crossing the chasm for that. Next slide. Oh yeah, there's a quote at the bottom. I like this one. This has been great. If y'all have a hackathon, I'd love to hear about it. So setting up for future events. If you click once more. So for future events, this we've already talked about this leading into maybe future hack weeks, even building this into learning cohorts. And we identified some opportunities where we could do a better job and improve on the people experience of this kind of workshop. Those are listed on this slide. And if you click once more, Amy, ultimately, all of this, the technical innovation part of it, the virtual data sets together with Earth Access, that relies on these opportunities to have user feedback and workshops. And the user workshops and feedback are only interesting because we're doing all of this development work as well. So they really feed back into each other and have tools and people co-working and evolving it all together. And that's all I have. So now I'll pass the baton to Julie to bring it home.
Great. Thank you so much, Danny, and Amy, and everybody. I love how I learn something every single time we give talks together. So it's fun to hear the latest synthesis from the Tempo workshop and virtualize our work. Hi, everybody. I'm Julie Lowndes. I lead Openscapes and get to work with Danny and Amy and many other amazing people at NASA and at NOAA Fisheries and beyond. And just in the last few minutes here, I wanted to share another story about crossing the chasm, and then share a little bit more specifically about our flywheel mechanism. So Amy, if you wouldn't mind advancing. Thanks. So we're thinking about how powerful all these tools and tooling are, and just how amazing it feels to have the skills to use these cutting edge early adopter tools. But on the next slide, it can also be really demoralizing when you don't have access or something's not working correctly. On a technical sort of daily level, we can all feel pretty low as you hit one of these struggles. And so having that community, having language around chasms and being able to isolate and describe the problem to others is a super important part of how all this development happens. On the next slide, I wanted to also think about this social and operational chasm rather than a technical chasm that also happens when you try to help an idea spread within a population. So on the next slide, the story I'll tell briefly is about how we've crossed the chasm with NOAA Fisheries, and really focusing on how data and workforce modernization is happening at NOAA Fisheries. This is the idea of having open science early adopters, having built this bridge, supported an early majority, and having these ideas spread in brand new ways, or I shouldn't say brand new ways, in increasingly synergistic ways throughout the agency. And this is work with Eli Holmes, who we've worked with for the last 5 years. She is at the Northwest Fisheries Science Center and is now the open science lead of this whole data and workforce modernization project at NOAA Fisheries. And Amy had mentioned her before. Thanks. Yeah, you can go ahead. So the little piece of this Crossing the Chasm story I wanted to talk about was that those early days of thinking about developing the early adopter community, how to find them, how to provide value so that they're able to give time and energy to the community and help them connect. And this really mirrors how Amy started off our talk talking about the NASA Openscapes mentor community and how we were able to create this space bringing folks together across different silos. So with NOAA Fisheries, we first had to find folks in order to create space to bring them together. And finding early adopters can be hard. And it's this social and organizational problem rather than a technical problem, like Danny was just describing. So on the next slide, we've spent a lot of time thinking about where would early adopters be. Not only are they rare, but they might not identify as early adopters. They might not know that what they're doing is new and different. So we worked to really, we realized that we could find them hidden among the R users. R is the main programming language used at NOAA Fisheries, a lot of statistical modeling, a lot of ecology modeling. And it was really in 2021 that things shifted with our momentum with building this early adopter community. There was an email list that was a cross-agency email list specifically about a statistical modeling community that we were able to use as a proxy of these are folks that are our users, they're early adopters. Openscapes was able to work with NOAA Fisheries in 2021 as well, and we led 4 of our 2-month-long champions cohorts to help people find each other across the agency, see what was hard, see what was working. And then really importantly, the NASA Openscapes project had started, like Amy had described. It started during COVID. We were gaining momentum. We were figuring out how to work across silos, tell stories, teach together in many different ways, both in person when we could, but starting off online. And that gave a blueprint for NOAA Fisheries to look at and say, we can do that too. These are our silos on this map and we want to connect them. So we really spent a lot of time helping identify and welcome and create value for these early adopters. Some of the ways that we provided value was by supporting a NOAA Fisheries R users group. That's something that Eli did early on and also helped connect them to a cross-agency R users working group. 1 second. Excuse me. And so that was this sort of value and connection so that we could think about crossing the chasm together. So that was the first step. And on the next slide, the second part of crossing the chasm was really to understand and help the early majority. You know, they're on the other side of a chasm. They have different problems, different needs, different motivations. What's interesting to early adopters and building and tinkering in many ways might not be what the early majority needs. So there is this really need for empathy, for partnering with different people to approach problems in different ways. And I think something that we don't have time to get into deeply here, but something that often happens when an idea fails to cross the chasm and kind of gets stuck in the chasm for all of time, it can be when the early adopters can get frustrated with the majority and think that they're not getting it, that they're not listening, that they're a lost cause. You know, there's all these different ways that personality and hurt feelings can make ideas not cross the chasm. So I think the approaches that Amy and Danny have just mentioned about really getting to know who is on the other side of the chasm, what their needs are, how to include them in the development. That was really a big part of what NOAA Fisheries has done here as well. And to focus on, picking this problem that's so painful that crossing the chasm is worth the risk and the work to get there, it is a big part of this theme. So on the next slide, at NOAA Fisheries, the problem so painful was big government reports. And this might sound familiar to folks at NCAR. This is certainly true in many different ways, shapes, and forms across NOAA Fisheries and beyond. There are, on many different frequencies, annual, biannual, shorter, longer periods of time where many people come together to produce a report. There's many different steps involved, QA, QC, compliance. A lot of things are handed off and never returned. And so the feedback loop and how things go together can be messy. Sometimes there's multiple years happening at once, and keeping this all on track can be really difficult. So we saw that this was the problem so painful. And on the next slide, something that NOAA Fisheries has been able to really support and cross this chasm with are improving workflows for big government reports, and doing this in a way that is not only immediately useful for a specific team required to do this report, but then having it be in a sort of forkable or reusable or extendable way for other groups to not only look at, see that they could do this too, but actually take a template or working code or an automated piece of a workflow and use it from there. So the tools that NOAA Fisheries is using are Quarto and our Studio and R in a lot of ways, but really importantly, this lets them output to whatever formats they want, whether that's Word or Google Docs or PDFs or slides. Citation and using Zenodos are a huge part of this. There are so many hundreds of citations in any of these reports that having a shared sort of database for your citations that are able to be read directly into this has just been game changing. And then all of this is version controlled on GitHub, not only with the source code and the source text, but also all of their shared to-do lists, rendering to these different formats. So this kind of life-changing workflow shift for a team and then for an agency is really is one example of this crossing the chasm. And the goals of the team themselves were really upheld throughout the whole process. And this example is from one of the teams, the Marine Mammal Stock Assessment Reports team, who are amazing and have been working on this and now teaching this for the past few years. But they were really, focused on the integrity, the collaboration, the reproducible process, incorporating new tooling, but making sure that folks could onboard and maintain whatever new tooling that they brought in, and really focused on compliance, QA, QC, all of the needs that are, make this an important government report for their stakeholders. On the next slide, so this is a short story about NOAA Fisheries, but really we've been growing this movement and really welcoming newcomers as contributors over the past few years. And if this sort of left to right are these three images you can think of as the left side was the early adopters on the left side of the chasm, where we had our first champions cohorts. And now, we're in this agency-wide training program rollout on the right side. And you can imagine that, back in 2020, we thought that we could hop over to this right side without this interim step. But you can imagine how this could have been a chasm where this idea didn't spread. We really had to think about what the problems were that people were facing and focus on hours of time to support them, welcome them, get past those troubleshooting bugs and whatnot. So on the next slide, thinking about a little bit about this mechanism and this Openscapes flywheel, and we'll be able to talk about this more with questions and discussions afterwards. But this is really it's a conceptual tool that's also an open source tool that you're welcome to use and fork and iterate as you need to. But this is on the next slide, Amy. this idea, this flywheel concept comes from Jim Collins, and it's really the idea that transformations occur from consistently doing key activities that add up over time. And Aaron Robinson and I codified this as we were working and seeing what was working as we built with the NASA mentors. So really the idea is that we're amplifying open leaders, we're engaging a future us mindset beyond our own computer or beyond our own day's work, and we're empowering this learning culture. And so there's 6 steps that, Amy, you can just kind of hop through all 6 of them, they'll animate. But it's really about reusing what's working already and then inspiring others to join, welcoming them when they join, creating space and place to collaborate, having real invested time in learning and trust, working openly together to build, and then the flywheel turns again. And so there's so much we can dig into this. I mean, this is a tool that I reach for when I'm planning or when I'm writing a report or when I'm feeling like something's stuck. I reach for the flywheel just like I would reach for R if I was going to be doing data analysis, or I'd reach for Earth access if I was accessing NASA Earthdata. But one thing I just wanted to leave us with here today is this one focusing on this creating space and place, because co-working is something that Amy and Danny have mentioned in different ways, and so I wanted to give a slide to think about this more deeply with you all. So if you animate this one, Amy, what is co-working? It's really this regularly scheduled time that people know about and they're able to come to, and it's not with people in their normal work team. So it's a chance to have awareness and exposure and build relationships with people outside of your normal teams. There has to be intention around it and helping facilitate conversations, particularly in the beginning, so that problems can surface rather than just what's working, because it's a lot of us are trained to talk about what's working and not what's not working. So helping identify the problems and helping people onboard to whatever tooling would help you build something together, whether that's using Google Slides for the first time or whether that's contributing a feature to a Python library. Like, those are different onboarding skill sets needed. But this sense of co-working is something that we started with the NASA mentors from day one, back during the pandemic. And from there, and from teaching together, the need for a specific time for Earth access came from that work together. And now that is something that you're all invited to as well. But yeah, so this is this concept that has really, we've seen shifting institutional culture with open science. And so this last reference here on the bottom right is a paper that mentors from NASA and NOAA and EPA and the Fred Hutch Cancer Center and California Water Boards and many other places we collaborated on sort of sharing this story and welcoming other people to try this in your own institutions as well. So I think our last slide is a thank you slide. Please join us, as Amy said, Amy and Danny said, at Earth Access. And also please keep an eye on the NASA Openscapes website as well. We'll have some other Earth Access events this fall, both virtually and in person at AGU, for folks that are going to be in New Orleans. So I'll say thanks from all of us again, and happy to take questions.
Yeah, hello. That was lovely. I feel like this is probably a good time to do some Q&A. Do you have the Slido stuff? Yeah, good? I don't have any on the Slido. No worries. I have some questions. One of the things I was wondering is, with Earth Access being kind of like a middleman between things, is there some sort of metric or back-end thing that allows people with the data to kind of know how do I say this? Like, what data is very popular? So like, what data, it's kind of nice to know where people are like interested in.
Yeah, that's a great question. And of course, like Danny, if you have some thoughts too, I could start off. But yes, you're totally right as far as Earth access leveraging and sort of being this like abstraction over other like backend APIs. So it would be, I'm actually not totally sure, come to think of it. So there's a broader API called the Common Metadata Repository that's really the house, it houses all the metadata of all archives. And I believe that there's some information you can infer there as far as like popularity. Whether you can actually do that through Earth access though, I don't believe so. But Danny, do you have any insight there?
Well, what comes to mind is kind of recently we were actually looking at the for any particular missions data, you can look into and find whether requests for that data have a particular header in the HTTP request that relates to Earth access. So Earth access puts header information into the request, and then on the back end we can see how many requests have that header in it. It's not simple to get that information, but it is there, and I kind of only started trying to tease that out.
Yeah, no, it's a great thing to look into, though. Definitely, I could see a user saying, "Hey, like, I don't know where to start. What are some
or
popular
from the
data
data
sets?" Yeah.
or from the data side, it could be useful for folks if they're knowing where or who's using the data to be able to potentially do extra things for that. I was also curious, like, this has been like a long process for you, I can see. Were there any like sort of unexpected needs that you sort of see arose when you were moving from those early adopters to a more wider base?
Great question. I have to reflect on
I'd
that.
say, and I mean, Amy, it'd be fun for you and Danny to riff too. The need for visuals came up really early. So the cheat sheets that PODAC, the Physical Oceanography Data Center, led early on was a big part of this too, like drawing out how people will experience accessing data in the cloud, and that became a big part of our cookbook, which maybe Amy, you want to speak more to.
That's a great example, and yes, a really big sort of outcome deliverable, if you will, of Openscapes as well was, yeah, this was not something we knew going into it, like nothing you proposed, Julie, to get funding for this effort, but we early on decided and realized through feedback that we needed to kind of have a centralized, what we're calling a cookbook, NASA Earthdata cookbook of tutorials, of reference materials, how-tos, and then these what we call cheat sheets to visualize like this complex workflow. That was something we started to develop right away, but was not something known to us that we needed to do per se. It was based on that feedback.
Oh, marvelous. Yeah, no, thank you. Also, I just wanted to highlight, you mentioned a little bit before the talk, the art, and it's very charming. So thank you for including some of that in there as well. All right.
I know we're at time here, but so developing a contributor community around an open source package is something that a lot of folks aspire to, but it's really, really difficult. Just wondering if you could share any thoughts. I mean, was there any secret sauce, something that you felt really, really worked well, or was just a combination of the many different things that you tried? What are your thoughts there?
Yeah, no, I mean, I think we're all looking for that secret sauce, and I'll say that by no means is, our community, like, I don't feel like we've reached any sort of perfection. I feel like, and that's maybe something in of itself, right? That we're always looking for ways to improve. Like I said, working on lowering barriers to contributions. I mean, I really think, what's obvious that we've already presented is those very consistent opportunities to come and work together through these biweekly hack days. Sometimes we'll just get a couple people attending. Sometimes it's like 20 people, which is really big. So that, I think the fact that like, hey, there's always this place to come to work. Another one I think that's maybe obvious, but I found it to be extremely helpful, and we have other contributors that have been fabulous at this, is just, it's very obvious, I think, in our repository that we're active and we respond quickly, right? And just knowing like, hey, there's someone there that's gonna respond to you, even if we don't have an answer or don't get to your issue right away, that it's active, and so there's a lot of people kind of with their eyes on the repository. I feel like there's a lot we can say on this too. I'd love for other thoughts, Danny and Julie, if you have any, but that's what comes to mind for me.
Yeah, I think there's that space and place that Julie mentioned is kind of a key. I mean, I don't know if it's the secret sauce and it's like some magical thing, but it forms. It does start to form those. It builds trust, I think, between people, and kind of, like in any relationship, the trust is the building block, so it's the foundation, and likewise for contributing to open source projects. So I think that's kind of the foundation, but then there's all of these additional tools and techniques that also help facilitate that trust building and make it practical. So there's Google Docs that we take notes on during the co-working sessions that everybody can add to and write into, and we have notes so that way everybody can see. And if you miss a meeting, you don't feel left out, you can look at the notes. If there's, of course, the GitHub issues and like Amy said, like responding quickly, but making sure that, there is that community online. And then there's other events that also build upon that kind of space and place. So at AGU, Julie mentioned there'd be a presence at AGU. At ESIP, Amy mentioned that we kind of had a retreat at ESIP. And so so not only is there the online space, but then there's these additional opportunities to kind of connect. And I think this slide that's still up there is sort of emblematic of that. So this is like from, I don't remember what particular online meeting this is from, but these kind of are emblematic of that participation and in just being able to talk openly about both the problems and the successes in these co-working type sessions.
Thanks. Of course. Thanks. Appreciate it.